Let us start our first unit on electrostatics. Here, electro means electric charge and statics means at rest. So we can say that electrostatics is the branch of physics that deals with study of charges at rest or charged bodies at rest. Let me share some of our daily life experiences and applications related to electrostatics. First, why we see a spark or hear a crackle sound when we take off our synthetic shirts or nylon sweaters on a dry weather. Why we feel a sensation of electric shock while opening the door of a car or when we try to hold the iron bar of a bus after sliding from our seats. Lightning that we see in the sky during thunderstorms. The reason behind all these is discharge of electric charges that were accumulated due to rubbing of insulating surfaces. Remember here, the human body acts as good conductor of electricity. Another set of daily life experiences are when the metallic bodies of cars and trucks get charged because of friction between them and air rushing past, and this large charge can produce even a spark. Such a spark can be dangerous in case of a petrol tanker, and that's why petrol tankers often have a metal chain dragging along the ground so that this charge leaks to the ground. However, nowadays the tires of cars and trucks are made by adding some carbon compound to the rubber for the safety. Now, applications. The attraction and repulsion between charged bodies have many industrial applications. Number one, in electrostatic loudspeaker. Number two, in electrostatic spraying of paints and powder coating. Number three, in fly ash collection in chimneys. Number four, in a Xerox copying machine. Number four, five, in the design of a cathode ray tube used in television and radar, and many more applications. Now, coming back to, let us focus on the concept of charge. The observations that when a glass rod is rubbed with a piece of silk, the glass rod acquires the property of attracting light objects like bits of paper, straw, pithball, dry leaves, or even dust particles towards it, show that glass rod is electrified or charged. Similarly, plastic rod on rubbing with woolen cloth also gets electrified. In daily life, too, we find a plastic comb get electrified on passing through hair, dry hair. So we can say, conclude that electric charges are produced due to friction between two insulating bodies which are rubbed against each other. The charges produced in this way on insulating bodies cannot move on their own, and that's why this phenomenon is called frictional electricity and also as static electricity. Historically, this phenomena was first noticed by Greeks in around 600 BC when they rubbed amber with woolen silken cloth. Amber is a yellow color resinous substance found on the shores of Baltic Sea. The name electricity is also derived from the Greek word electron, meaning amber. Now, coming to page 2 of NCERT book, let us go through few experiments, simple experiments done with the help of glass and plastic rod and rubbing with silken and woolen cloth or with fur and by using two pith balls. As you can see, when a charger glass rod is brought near another charged glass rod, repulsion is there. Similar effect is seen when a charged plastic rod is brought near another charged plastic rod. But when a charged plastic rod is brought near glass rod, a charged glass rod, then attraction is noticed. In second experiment with the pith balls, when the charged rod is touched, that charged glass rod is touched with the balls, we can conclude that repulsion from like charges repel each other from the rod, unlike charges attract each other. These experiments also demonstrate that the charges are transferred from the charged rod to the pith balls on contact. The property which differentiates the two kinds of charges is called polarity of charge. So we can now define charge. Electric charge is an intrinsic property of elementary particles of matter which give rise to electric force between various objects. Further, from these experiments, we can see that if the charger rod is brought in contact with the silk, that is, with which glass rod was rubbed, then they no longer attract each other. And they also do not attract or repel other light objects as they did earlier. This clearly indicates that charges acquired after rubbing are lost when the charged bodies are brought in contact again. So it can be easily concluded that unlike charges acquired by the two objects neutralize or nullify each other's effect. So American scientist Benjamin Franklin named the two kinds of charges as positive and negative. So by convention, the kind of electrification acquired by glass rod as positive after rubbing with silk and that acquired by plastic rod as a negative after rubbing with woolen. To detect the presence of charge on the body, to detect the presence of charge on the body, the device is gold leaf electroscope. You can see this device in your lab when your schools reopen. and you can see the construction of this gold leaf electroscope. It consists of a vertical metal rod housed in a box with the two thin gold leaves attached to its bottom end. When a charged object touches the metal knob at the top of the rod, charge flows onto the leaves and they diverge. The degree of divergence is an indication of the amount of charge. Students, you can too make a simple electroscope as mentioned on the page number 4 of your NCERT book and try the results. Thanks.